Hello and welcome to the third video in our HDM theory lessons. This particular video concerns rapid prototyping. Now hopefully you have a bit of an understanding about what rapid prototyping actually is. This will give a bit of an overview and hopefully pick out a few key points. First off, I should apologise for the look of the video. I was hoping to have a similar look to the other ones, just didn't have enough time to get that out. So I'm afraid you're going to have to put up with how this one looks. The content would be the same, it's just it doesn't look quite as nice. The graphics are there to try and help, I guess, kind of anchor these thoughts and ideas and concepts with a few images. So first of all, rapid prototyping at its very core is a modelling technique. Communication and development at the top of the screen there pretty much relate to any modelling that you do. Modelling is a communication tool in that you can use it to discuss ideas with other members of the design team, with the hope that in doing so you kind of spur on creativity, or you are able to work out a problem that's arisen in the design process. And models allow us to do that. They're physical, tangible things we can get our hands on and pass them around the team. The other side of modelling and its real importance in the design process is just in the development of that model, or the design I should say. Again, what it allows us to do is to pick holes to discuss and to work things out perhaps. Maybe it'll be to do with a range of movement that a model is able to show us. Maybe it's a proof of concept. So rapid prototyping is a modelling technique, and it allows us to communicate and develop our ideas, just like any modelling technique. The ones that are specific, the points that you have to raise specifically to rapid prototyping though, are the ones in blue at the bottom. That's speed, accuracy, changes and testing. So to take them one at a time, rapid prototyping isn't fast, but it is faster than making prototypes in the workshop. What it also allows us to do is multitask. So, a part may take several hours to print out rapid prototyping, that part, but at that same time, you'll be doing other things. So perhaps you're making, another CAD model. You could be doing any manner of things to do with the design process. So it allows us to multitask. So it's not exactly fast. It doesn't print them in seconds, but it does allow us to, it prints them faster than it would take to make them by hand. And it also gives us that gift of time. As the machine's printing these things out, we're doing something else. The accuracy is also really important. Rapid prototyping is a very accurate process. If we've spent a lot of time and effort making a very accurate CAD model, this ensures that the part is being produced to fractions of a millimeter in terms of the accuracy. So if you're wanting parts to fit together, or if you're wanting to check anthropometrics, you can be sure that when you rapid prototype something, it has printed it out really accurately indeed. The changes that can be made to the design are really important. So where you might have spent hours and hours and hours, say for example making say like an iron, you might find that the actual handle at the top of the iron is too narrow. Okay, so you've checked it out with 95th percentile grip size. Those people are saying, no, this feels too flimsy, it's too small. Now, with an old school model made in the workshop, that might be really hard to make those changes to that model. In rapid prototyping, we just go back to our computer. Within potentially minutes, we can have that handle made slightly larger, wider, whatever it is, and then printed out again. Again, changes can be made really, really straightforwardly. And then finally, testing. We can now print out stuff in the actual material it will be made from in the real world. So, for example, with the clip that's shown in that image, that's likely to be made from ABS. We can print that out in ABS and then use it again as a communication development tool, passing it around the team saying, look, are we happy with how secure this feels? Does it make a satisfying click as it goes into the other part of the clip? And do we feel it's going to come apart? Again, if any of those answers are in the negative, then we can make those changes very quickly on the computer, print it out again, and have that discussion again. So again, it kind of ties back to that accuracy thing. If we've spent time making this clip for your bag, we know that the model that's printed out is going to be printed out really, really accurately. So in a nutshell, that's rapid prototyping. It allows us to do the standard classic things that any model allows us to do. It's a communication tool, it's a development tool, but it also allows us to multitask. We don't need someone standing in a workshop just producing these prototypes. We hit print on the printer, it prints it for us while we're doing other stuff. It's very accurate, so again, you could argue that it would be more accurate than making it by hand. Changes are easy to made. It just takes a few clicks on a mouse, and the changes can be made. The part can be printed again. And then finally, testing. We're able to do some actual physical testing of parts if we're needing things to be, for example, interference fitted. So that's rapid prototyping. I'd recommend having a look on YouTube just for some videos that just demonstrate the actual process itself. There's some really, really nice ones out there. Last thing I should add is there's two main types. One of them is called STL, which stands for stereolithography. That uses a laser which solidifies plastic within this kind of vat. Again, you might want to YouTube that. And the other type of rapid prototyping is powder, which is almost similar to an inkjet printer. It sprays down layers of this powder and a kind of binding agent, and as it passes backwards and forwards, it builds up this physical 3D thing. So that's powder printing and STL, stereolithography, rapid prototyping. Have a wee look on YouTube for those. Okay, thanks. Bye.